Okay, Assalamualaikum and hi everyone. So, in this video, we are going to discuss chapter 6.3 Chemical Properties of Benzene. Okay, so maksudnya kita akan belajar reaction of benzene sahaja dalam video ni. Okay. Alright, so learning outcome kita adalah to explain the electrophilic aromatic substitution reaction of benzene. There are 4 reaction of benzene. Okay, nitration, halogenation, Friedel-Craft Acylation and Friedel-Craft Acylation. Okay. And after that you need to illustrate the mechanism for all reaction, tapi mechanism kita akan cover dalam video yang lain. Okay, but learning outcome C saya akan cover together in this video lah, sebab learning outcome C ni adalah reaction juga, cuma reaction tu bukan pada benzene directly but pada side chain yang attached to benzene. Okay, so kita akan tengok oxidation reaction by using KMnO4 or potassium dichromate. And then halogenation, which is free radical substitution yang kita dah pernah jumpa dalam topik alkane before this same reaction sahaja. Okay, let us proceed. Okay, for introduction, introduction kita tengoklah. Okay, so first adalah benzene will undergo substitution reaction but not addition reaction. Okay, so ini untuk clarify statement beza antara benzene dengan alkane lah, sebab benzene mungkin ada ramai yang akan cakap, oh benzene ni samalah macam alkane because alkane ada double bond, benzene ada double bond. Okay, tak, dia tak sama. Okay, alkane undergo addition reaction whereby the double bond tukar jadi single bond. Okay, but for benzene dia tak undergo addition reaction tapi dia undergo substitution reaction. That means the double bond inside the benzene ring will remain as double bond. Yang dekat luar ni, hidrogen ni ya sahaja yang akan ditukar kepada substituen lain lah. Okay, so satu hidrogen je yang kita akan tukar kepada substituen lain. Okay, kenapa benzene tak boleh undergo addition reaction? Sebab dekat bawah ni, because stability of pi electron system will be lost if benzene undergo addition reaction. Okay, for your information, benzene is very stable. Okay, sebab apa dia stable? Because the pi electron system dalam ni boleh delocalize, dia boleh gerak. Okay, so the pi bond ataupun the benzene ring itself very stable. Okay, so bila very stable, dia tak naklah jadi benda yang dia tak stable. Okay, dia akan kekalkan keadaan dia yang stable tu. So that's why benzene cannot undergo addition, because if benzene undergo addition, one of the double bond akan hilang. Okay, dia akan hilang sebab benda lain yang akan attach to benda ni. Okay, so keadaan ni menyebabkan dia tak stabil. Okay, so ini yang lebih stabil. Alright, so that's why benzene will not undergo addition reaction but it will undergo substitution reaction. Please remember that. Okay, and then reaction of benzene ada terbahagi kepada dua lah, macam saya explain dekat learning outcome tadi. Okay, reaction yang involve dekat benzene ring tu sendiri. Okay, dan reaction yang involve dekat substituent attached to benzene ring. That means benzene ring tu ada side chain. And then reaction tu berlaku di side chain, bukan di benzene ring. Okay, so kita akan discuss dua jenis reaction tu lah. Okay, so let us start with the first reaction, which is reaction of benzene involve the benzene ring itself. That means reaction ni berlaku betul-betul dekat benzene ring. Okay, ada 4 total reaction yang berlaku dekat benzene ring. And the first one is halogenation. Okay, for your information, type of reaction semua adalah electrophilic aromatic substitution. Nanti kita tengok. Okay, and then next one is the reagent. Since the halogenation, that means it will involve halogen. Okay, for example Cl2 or Br2. And then for this reaction, we will need to use catalyst. Okay, the catalyst yang kita akan guna adalah Lewis acid. Okay, so this Lewis acid, example dia adalah AlCl3, AlBr3, FeCl3 or FeBr3. Okay, but in exam, kamu pilih salah satu je lah. If you use Cl as your reagent, so choice of Lewis acid yang kamu ada adalah AlCl3 and FeCl3. Okay, it is better for you to use Cl dengan yang Cl juga. Kalau kamu guna Br, dengan Br dan Br ni lah. Okay, or salah satu sahaja. Okay, and your product is halobenzene. Okay, halobenzene means benzene tu ada and attached to element in group 17 lah. So dia jadi halobenzene. Okay, this one very simple. Okay, so kamu ada benzene seketul. Okay, reacted dengan bromine. Okay, and then in exam, kamu pilihlah salah satu daripada benda ni. Tapi ini nota kan, so saya provide dua benda kat kamu. So let's say lah, you just choose Br2N, AlBr3. So this is substitution reaction. Okay, kita akan substitute one of the hydrogen yang dekat tepi benzene ni. Okay, kita akan substitute dengan Br. Okay, so simple sahaja dia punya reaction. Okay, so the double bond remain and then choose lah any side yang kamu nak letak Br. Okay, you can place anywhere because if you place it here, nama dia masih sama dengan kamu letak dekat sini. Okay, alright, so this is our product. Kalau nak tengok side product dia bolehlah HBr. Okay. So for this one, dia ada observation because I already mentioned to you bromine ni dia ada colour and the colour of bromine initially adalah reddish brown colour. But when the reaction occur, the reddish brown colour tu decolorize. That means dia dah jadi colourless lah. So at the end, kita dah tak nampak dah reddish brown tu. Kita nampak colourless solution sahaja. Okay, so that is the first reaction which is halogenation. Okay. Oh, before that, tadi saya ada cakap, I want to explain kenapa this is electrophilic aromatic substitution. Okay, as you can see from benzene pergi produk, okay, so produk kita berlakunya substitution, okay, because this hydrogen keluar and then combine with one of this Br here and then another Br substitute dekat sini lah. Okay, so dapatlah this product. So that's why the name is substitution. But then why electrophilic? Okay, you have to remember benzene. Okay, kita ada double bond, kita ada triple bond, kita ada benzene ring. Ketiga-tiga ni adalah kawasan nucleophilic site. Okay, so nucleophilic site means kawasan yang kaya elektron. And I told you in Chapter 4, okay, reaction that occur at nucleophilic site, reaction tu akan jadi opposite nama dia. Okay, so that's why the name is electrophilic. Okay, and kenapa ada the word aromatic? The word aromatic here sebab dia benzene. Okay, benzene kan aromatic compound. Kan kita belajar awal-awal requirement for aromatic. Okay, alright, so you should know kenapa dia electrophilic aromatic substitution. Okay, any problem you can contact me lah. Alright. Okay, and then next one is nitration. Okay, nitration pun senang juga. Cuma nitration from the word nitrate tu you should be able to guess lah. This one will involve nitrogen lah. Okay, type of reaction still sama. Electrophilic aromatic substitution. That's mean we will substitute hydrogen dekat benzene tu. Okay, but our reagent kali ni lain sikit. Concentrated nitric acid HNO3 and concentrated sulfuric acid. And the condition is 50 to 55 degrees Celsius. Our product will be nitro substituted compound. That means benzene ring tu akan ada nitro compound, nitro substituted dekat dia lah. Okay, so cara untuk tulis kita punya reagent macam ni. Okay, so benzene reacted dengan concentrated nitric acid. Ada concentrated sulfuric. The temperature is 50 to 55 degrees Celsius. Tolong tambah. Okay, and then our product. Okay, so nitro. Nitro is NO2 lah. Okay, so maksudnya you should get your benzene ring attached with NO2. This is what we call nitrobenzene. Okay, so this nitrobenzene pun dia ada observation. Observation dia adalah yellow oil is formed. That means something, dia bukan yellow oil yang kita masak tu, tak. Okay, that means dia punya texture dia tu nampak macam oil. Okay, and the colour is yellow. So, kalau oil means water insoluble lah. Almond like odor. That means dia bau macam badam lah. Okay. Alright. So, settle. For me, these two reaction is quite simple. Okay, so next kita tengok Friedel-Craft Acylation. Okay, Friedel-Craft ni nama orang. Okay, Acylation. Dia almost similar the name. Okay, one alkylation, another one is acylation. Okay, since the word dia alkylation, that means dia involve alkyl group. Okay, alkyl group tu R lah yang saya simbolkan R. Okay, and alkyl group can be CH3, CH2, CH3 ataupun berapa banyak carbon pun doesn't matter lah. Okay, alright, that is alkyl group. Okay, so type of reaction still the same, electrophilic aromatic substitution. Our reagent this time adalah haloalkane. That means alkane yang attached to halogen. Okay, catalyst masih sama. Okay, and betulkan sini L kecil. Alright. And then our product will be alkyl benzene, maksudnya ada benzene and ada alkyl group attached to that benzene. Rearrangement may occur here is for mechanism. Okay, so maksudnya when we write the mechanism later on, we need to check the carbocation punya class. Okay, if possible for rearrangement, that means if possible for us to form more stable carbocation, then we will shift lah. Okay, kita ada dua pilihan shift hari tu kan, 1,2 methyl shift and 1,2 hydride shift. That means ada possibility for shifting dekat Friedel-Craft Acylation. Okay, so mechanism nanti kita tengok. Just saya remind je kamu dekat sini. Okay, so for this one pun tak adalah susah sangat. Okay, so the reagent CH3Cl which is the haloalkane tadi. Okay, ini adalah chloromethane reacted dengan benzene. Okay, so what happen adalah the bond between CH3 and Cl ni will break. Okay, and up this carbon akan jadi carbocation. Okay, and then this carbocation akan substitute one of the hydrogen dekat benzene ring lah. So our product will be benzene ring attached to CH3. Okay, and side product HCl lah logically, because this hydrogen keluar combine with this Cl here. Okay. Right, so itu example yang paling senang lah. Okay, kalau yang lain sikit for this structure here, haloalkane juga. Okay, so for this haloalkane, what happen adalah this Cl akan keluar. So, carbon yang akan bonded with this benzene adalah carbon yang tengah ni lah, carbon yang putus dengan Cl tu. Okay, not this carbon, not this carbon. Okay, so kena pandai kita tengok lah. So remember Cl yang attached to carbon tu yang akan bonded to benzene. Okay, so our product will be benzene ring and then attached to C yang ada H, then ada CH3, ada CH3. Okay, so itu produk kita, and Cl tadi keluar together with HCl. Right, okay, done. That is Friedel-Craft Acylation. So next is Friedel-Craft Acylation. Okay, so kalau alkyl is alkyl group tu lah. Okay, acylation is this group here. So C double bond O attach dengan carbon yang lain, alkyl group. Tapi over here depend lah. Kadang-kadang dia attach dengan Cl, kadang-kadang dia attach dengan Br. Ikut nama dia. Okay, so kita tengok reagent. Okay, our reagent is acyl chloride. Okay, so this is acyl. Kalau nak jadikan dia acyl chloride, that means kita letak Cl over here lah. So, dia jadi acyl chloride. Okay, tapi kalau nak jadikan dia acyl bromide, over here we change it to Br. Okay, so this one jadi acyl bromide. RC double bond O. Okay, RC double bond O and then Cl atau Br. Okay, so this one, our catalyst will be Lewis acid, sama juga, AlCl3. And our product will be ketone. Okay, so ketone, hopefully you still remember, ketone adalah C double bond O, kiri kanan dia alkyl group. Okay, alright, so ini pun sama macam Friedel-Craft Acylation tadi. We need to break the bond antara C dan Cl tu. So C dan Cl tu akan keluar, and up this carbon will become carbocation. Okay, so this carbocation lah yang akan substitute hydrogen yang dekat benzene. Okay, so our product will be benzene bonded with, since Cl ni attached to this carbon, so this carbon lah yang akan bonded to benzene. So maksudnya carbon double bond O attached to CH3. So this is our product, and ketone sebab ialah C double bond O, kiri kanan carbon. Okay, so that's all for reaction yang occur at benzene ring. Okay, next kita nak tengok reaction of benzene ring juga, tapi dekat side chain. Okay, and these two reaction is not something new, bukan reaction baru, tapi kamu dah tahu dah sedikit. Okay, this one is oxidation reaction. Okay, oxidizing agent so far yang kita jumpa adalah KMnO4, potassium permanganate, or potassium dichromate, or sodium dichromate. Tiga-tiganya adalah strong oxidizing agent. That means it will oxidize until the end lah. Okay, and then the condition must be acidified and hot. Okay, so over here H ni plus dia kecil atas tu. H plus, tolong betulkan. Okay, and our product will be benzoic acid, or depend lah. Benzoic acid tu maksudnya benzene yang attached to COOH. Okay, so this is benzoic acid. Tapi tak semestinya semua benzoic acid lah. Maksud saya benzene dan COH tu ada, tapi maybe structure dia akan lain, depend pada structure lain jugalah. Okay, and then ini yang penting. Okay, not all side chain tu can be oxidized. Tak semua side chain boleh oxidize. Okay, for oxidation reaction to occur at side chain, the side chain must have at least a benzylic hydrogen. Okay, so syarat dia untuk oxidation tu berlaku, carbon yang attached to benzene ring tu mesti ada at least satu hydrogen, dan hydrogen tu kita panggil dia benzylic hydrogen. Okay, what is benzylic hydrogen? Hydrogen that attached to carbon atom that bonded directly to benzene ring. Okay, you can see this diagram bawah ni. Okay, so this carbon attached to 3 hydrogen. Okay, and this hydrogen attached to carbon yang attached directly to benzene. Okay, so itu maksudnya this hydrogen, tiga-tiga ni kita panggil dia benzylic hydrogen. Okay, alright, so ini pun sama juga condition dia. Okay, this one lain sikit. So this this H bonded to this carbon. Okay, so maksudnya dia ada H dekat sini lah. Okay, so H dekat sini, so H ni bonded to this carbon, and this carbon bonded directly to benzene. So this H adalah benzylic hydrogen. Okay, alright. Tapi H yang dekat sini, yang CH3 ni tak. This is not benzylic hydrogen. Okay, kenapa dia bukan benzylic hydrogen? Sebab this H bonded to this carbon. Okay, carbon ni. Carbon ni bukan carbon yang bonded direct to benzene. Okay, right. So itu cara untuk identify benzylic hydrogen. Okay, so compound without benzylic hydrogen are inert to oxidation. That means kalau compound tu tak ada benzylic hydrogen, that side chain will not be oxidized lah. Dia tak akan teroxidize. Okay, right. So kita tengok example. Sini saya bagi banyak sikit example sebab dia depend pada situation lah. Okay, for example over here we have benzene. Okay, and then KMnO4 H plus heat. Okay, so we know that this is oxidation. Okay, and then ada CH3. Okay, so this H ni benzylic hydrogen ke tak? Okay, logically this hydrogen adalah benzylic hydrogen lah. Okay, sebabnya hydrogen ni attached dengan this carbon. Carbon ni directly attached dengan benzene ring. Okay, alright. Okay, so bila ada benzylic hydrogen, so produk kita adalah benzoic acid. So kita akan draw balik kita punya structure benzene. This CH3 will be oxidized to COOH. Okay, you don't have to think about number of carbon whatsoever. Dia memang terus akan tukar jadi COOH. Okay, that is example 1. Alright, so let us look at example 2. Okay, so for example 2 saya bagi skeletal structure, but over here sama lah. This is CH3, this is CH, this one is CH3, CH3. Okay, so since tengah ni, carbon yang directly bonded to benzene ni ada H, and this H adalah benzylic hydrogen. So, maksudnya adalah possibility untuk oxidation tu berlaku. Okay, so ini boleh, that means this carbon ni semua boleh oxidize. Ini pun boleh oxidize sebab ada benzylic hydrogen. So, our product will be benzene ring yang bonded to COOH, and over here also bonded to COOH. Okay, and mesti kamu pelik, kenapa? Ini ada 1, 2, 3 carbon. Kenapa sini satu? Okay, dia memang macam tu. Regardless of the number of carbon yang ada dekat sini, as long as dia ada benzylic hydrogen, boleh oxidize. Kalau ada 100 carbon pun dekat luar ni, dia akan still jadi COOH sahaja. Okay, itu tips dia. Okay, regardless of the number of carbon, it will be oxidized to COOH only. Okay. Okay, so next example 3. Okay, untuk example 3 kita guna sodium dichromate as our oxidizing agent. So, dia akan oxidize CH3 to COOH, but for NO2 it will remain as NO2 because dia tak oxidize lah. Okay, alright, so next is example 4. Okay, for example 4, structure kita nak lebih kurang macam atas ni, tapi lain sikit. So, dekat ujung ni still kita ada CH3, but over here kita ada carbon. Okay, so basically this carbon that attached directly to benzene tak ada benzylic hydrogen. Okay, so over here no benzylic hydrogen. So saya cakap tadi, if no benzylic hydrogen, that means this side chain is inert to oxidation reaction. That means it will remain as it is lah. Okay, and for this one je yang akan tukar jadi COOH. Okay, so done, siap. Okay, that is oxidation reaction at side chain. Okay, and then next one kita nak tengok halogenation. Okay, for halogenation, type of reaction dia adalah free radical substitution. Okay, so this is similar mechanism to halogenation of alkane. So, sebab side chain yang dekat benzene tu adalah alkane. So, maksudnya reaction tu adalah free radical substitution yang sama macam alkane lah. Alright, so janganlah rasa pelik. Okay, so our reagent adalah halogen. That means can be bromine or chlorine lah. Okay, so condition dia wajib ada UV or HNu. Okay, alright, so let's say lah first saya guna chlorine UV. Okay, so kalau saya guna chlorine UV, the product will be at the side chain. Tapi kalau saya tukar, let's say lah saya tak guna UV, saya guna chlorine, lepas tu saya letak AlCl3. So, kalau ini back to reaction kita awal-awal tadi, which is this reaction here. Okay, so ingat, sikit je ubah, terus jadi produk lain. Okay, alright, so back to this one. Okay, so this one tadi saya nak UV kan. So, bila ada UV, that means the reaction occur at alkane. So, this benzene ring remain as benzene ring. This CH3 jadi CH2 and attached to Cl. Okay, alright. And then, next one is this structure here. Okay, so this structure benzene, ini secondary. Ini primary. Okay, kenapa saya nak determine secondary primary? Because kita ada major product, kita ada minor product lah untuk Cl2 UV ni. Okay, so kita belajar, recall balik. Okay, Cl ni akan substitute tempat yang tertiary kalau ada. Okay, kalau tak ada, secondary. So, sebab kalau ada yang tertiary, Cl substitute situ, dia akan jadi major product lah. Tapi for this one, we only have secondary carbon, we only have primary carbon. So, the best choice is secondary carbon lah. So, maksudnya our major product akan jadi macam ni. So, Cl attached to carbon yang secondary. This is our major product. Okay. And for minor product, Cl akan attach dekat hujung lah. So, ini reaction halogenation. Okay. Last sekali kita nak tengok stability of benzyl radical. Okay, kenapa tiba-tiba muncul benzyl radical ni? Okay, benzyl radical ni muncul sebab tadi baru je reaction tadi adalah free radical substitution. Okay, so bila free radical substitution, example dekat sini, Cl ni boleh masuk, but before Cl ni masuk, actually what happen adalah that benzene ring tu, ada CH2 ni, ada radical dekat sini. Okay, and then only baru Cl tu datang kan, ingat balik mekanisme lah. Alright, so this benzyl radical ni, okay, benzyl lah kan, CH2 attached dengan benzene, we call it as benzyl. Benzyl radical ni stable, lagi stable daripada tertiary free radical. Ingat lagi tertiary free radical macam mana? Tertiary free radical means carbon tu ada radical and attached to 3 alkyl group lah. So, this is tertiary free radical. Kalau ikut kita belajar, tertiary free radical paling stable lah compared to secondary and primary. But, if you compare tertiary free radical with benzyl free radical, okay, benzyl free radical ni lebih stable. Okay, sebab dia kenapa? Okay, sebab ni. Okay, as you can see, the radical can be delocalized. Okay, kita boleh gerakkan that radical. That radical we will not stick in one position, tapi dia akan bergerak-gerak dalam ring ni. So, dalam organic chemistry, kalau dia boleh gerak-gerak lagi macam tu, lagi stable lah. Okay. Alright, so I think that's all for reaction of benzene. Okay, in the next video, I will continue with mechanism. Okay, thank you semua. Bye.